Hello friends, welcome to my channel. In this video I will cover ISRO scientist RAC 2017. This is part 3. Question is, in aircraft air refrigeration system used because of low weight per ton of refrigeration, Bell-Coleman cycle. Low weight per ton of refrigeration. That's why we are using air refrigeration system in aircraft. A reversible engine has maximum thermal efficiency of 30% when it is used as refrigerating machine with all other conditions unchanged. The coefficient of performance will be how much? So one formula is there, efficiency of heat engine into COP of heat pump, it's equal to 1. So first we will calculate COP of heat pump. It's 1 by efficiency 30%, so 0.3 or 10 by 3 you will get. Then COP of refrigerator they ask, it's equal to COP of heat pump minus 1. So 10 by 3 minus 1 you will get 7 by 3. So 2 point something, 2.33. B is your correct answer. In vapor compression system, the condition of refrigerator before passing through the condenser. Before passing through the condenser, if you follow TS diagram or PS diagram also you can draw. One to 2 is compression, 2 to 3 condensation, 3 to 4 is your capillary, then 4 to 1 is evaporation. So here they ask condition of refrigerator before passing through the condenser. So at 2 point it's superheated only. So superheated vapor. D is your correct answer. This line is your saturated vapor line. And this line is your saturated liquid line. This is not line, this is curve. Lithium bromide in vapor absorption refrigerating system. Lithium bromide is absorbent and refrigerant is your water. So lithium bromide refrigerant, it's absorbent, refrigerant is your water. Both you have to remember. In refrigeration cycle, subcooling occurs when latent heat from refrigerant is removed. Latent heat, subcooling. After condensation only we are doing subcooling. If you will draw the pH chart, pressure versus enthalpy chart. Subcooling will do here. Initially 1 to 2, 3 to 4, like this subcooling we are doing here. 3 to 3 dash, it's subcooling. So due to subcooling your COP increases because 4 dash to 4 is 4 dash to 1 is greater than 4 to 1 enthalpy. So here this is latent heat during phase change only. So this point to this point 3 to, let this point is 2 dash, 3 to 2 dash is your latent heat and 3 to 3 dash this is sensible heat. So latent heat from refrigerant is removed. No. This point is 2 dash to 3, only latent heat removed. But we are doing in subcooling 3 to 3 dash. So sensible heat from refrigerant is removed. D is your correct answer. B is your correct answer. For air with relative humidity 80%, phi equal to 80%. The dry bulb temperature is less than wet bulb temperature. The dew point is temperature is less than wet bulb temperature. Yes. B is your correct. dew point temperature is less than wet bulb temperature. During evaporative cooling process, the wet bulb temperature it remains constant. WBT is constant. So from option C is your correct answer. In a psychometric process, the sensible heat added is 30 kJ per second and latent heat added is 20 kJ per second. The sensible heat factor for the process is how much? So, if process is like this in psychometric chart, this is from 1 to 3. 1 to 2 is your sensible heat and 2 to 3 is your latent heat. So, sensible heat factor we have to calculate SHF. It's sensible heat by sensible heat plus latent heat. So, sensible heat is how much? It's 30 kJ per second. And sensible heat is 30 plus 20, so 30 by 50 or 3 by 5. 3 by 5 is 0.6. B is your correct answer. The bypass factor of cooling coil decreases with option decrease in fin spacing and increase in number of rows. Yes. A is your correct answer. Bypass factor decreases with decrease in fin spacing and increase in number of rows. Final difference by initial difference, that is bypass factor. The wet bulb depression is 0 when relative humidity phi is 100%. That time wet bulb depression is 0. D is your correct answer. Next question. In the metal coating process, the high cutting speed and large angle of tool will result in formation of higher cutting speed means VC is high and large angle of tool means back rack angle or rack angle is high. That time you will get continuous chip. Higher cutting speed and large angle of the tool. Next question. Gear hubbing process produces more accurate gears than milling because in hubbing there is continuous indexing operation. Yes. A is correct. The type of tool used in milling machine and broaching machine, both are multi-point cutting tool. So from option D is your correct answer. Question is, Ackermann steering gear mechanism is preferred to Davy steering mechanism because whole of the mechanism in the Ackermann steering gear is on the back of the front wheels. A is your correct answer. This is your official answer. The natural frequency of free torsional vibration of a shaft with torsional stiffness Q and I is the mass moment of inertia of the disc attached to the end of the shaft is how much? So we have to calculate natural frequency. Omega n we have to calculate. We know omega n, our formula is K by m root over and K equal to K into delta equal to W. W is the load and here stiffness is K equal to W by delta. But in case of torsion it's different. In case of torsional stiffness T by theta, we can here they are writing this one as Q, and in case of M, K will replace with Q and M will replace with moment of inertia. So omega n you will get q by I root over. From option 2 pi is available, so it's in Hertz. Omega n unit is radian per second. Here 1 by 2 pi also available, so it's in Hertz term. So Fn equal to 1 by 2 pi q by I. C is your correct answer. A is a 3 cross 4 real matrix and Ax equal to B is consistent system of equation. The highest possible rank of A is, so highest possible rank is 3, because here number of rows is 3 and it's consistent. C is your correct answer. The value of quantity P where P equal to 0 to 1 x e to the power x dx. So integration by parts we will use here. U equal to x, then dv equal to e to the power x dx. From here we will get du equal to dx and v will get e to the power x. So our integration will become 0 to 1 uv minus v du integration. 0 to 1 u into v x e to the power x minus integration from lower limit 0 to 1 v du v is e to the power x, du is dx, its integration 0 to 1. So x e to the power x minus e to the power x. Put the value. B is your correct answer. The solution of differential equation solution we have to calculate. So here y dy equal to minus x dx. Do the integration both sides. Plus c by 2 we will put. Then y square plus x square by 2 equal to c by 2. So y square plus x square equal to c. Then initial condition given x equal to 1, y equal to root 3. So here we will get y square is 3 plus 1 square is 1. So c value is 4. So put the value here, y square plus x square, c equal to 4. This is your solution. The analytic function f of z, its singularities we have to calculate. So z square plus 1, it's equal to 0. So z square equal to minus 1, z equal to plus or minus 1 root over. Or so from option D is your correct answer. The equation e to the power x minus 1 equal to 0 is required to be solved using Newton's method with an initial guess of x0 given, it's minus 1. So x1 value we have to calculate. So our formula is, so f of x is e to the power x minus 1, it's equal to 0. Then initial is minus 1, x1 value we have to calculate, x1 equal to, our formula is x0 minus f of x0 by f dash x0, f of x0 upon f dash x0. So here f of x we got f dash x equal to e to the power x, then for f of x0, x0 is minus 1, so e to the power minus 1 or 1 by e minus 1, then f dash x0, it's 1 by e, so just put the values, x0 is minus 1 minus f of x0, 1 by e minus 1, if you solve this one, finally you will get e cancel, then e minus 2, e value is 2.71 minus 2, 0.718. A is your correct answer. Laplace transform of f of t, it's equal to t square sin t. So here t square given, so 2 times we have to do the differentiation. F of t is t square sin t. So in step 1, first Laplace of sin t we will do. Laplace of sin t, direct formula is there, 1 by a square plus 1, this is equal to f of s, capital F s. So then in second step we will multiply t square, so Laplace of t square sin t, we know Laplace of t to the power n sin t, we will get minus 1 to the power n d by d to the power n f of s. So f of s is 1 by a square plus 1, so we will do minus 1 h square t square, so minus 1 to the power 2 only, 2 times differentiation we have to do, 1 by a square plus 1, u by v formula, if you solve further you will get like this. It's into 6a square minus 2, or you can write 2 by a square plus 1, it's q into 3 a square minus 1. So from option B is your correct answer. The residue of a complex function given at its pole, its residue we have to find out. So its poles are 0, from z minus 1 you will get 1, from z minus 2 you will get 2. So poles are 0, 1, 2, 3. Then we have to calculate residue. At z equal to 0, first we will calculate. Residue is z minus 0. F of z is 1 minus 2z by at z equal to 0. You will get 1 by minus 2 minus 1, you will get 2. So 1 by 2 for z equal to 0. Then for z equal to 1, z minus a is into f of z minus 1, z minus 2 at z equal to, so at z equal to 1 you will get 1 minus 2 then minus 1, and again at z equal to 2 residue is z minus a z equal to 2. 1 minus 4 by 2 into 2 minus 1 is 1, so you will get minus 3 by 2. So residue are for 0 it's 1 by 2, for 1 it's 1, and for 2 it's minus 3 by 2. C is your correct answer. The solution of the differential equation. So differential equation given, you have to find out the solution. So from here we can write dy by dx equal to minus y square, or dy by y square it's equal to minus dx. Then integrate minus x minus c we will take. Minus 1 by y equal to minus x minus c. So x minus 1 by y equal to minus c, or x plus c equal to 1 by y, or y value solution we have to calculate. So from option A is your correct answer. Question from probability. A box contains 10 screws, 3 of which are defective. 2 screws are drawn at random with replacement. The probability that none of the 2 screws will be defective is how much? So total screw available it's 10, out of which 3 defective and 7 is good. Then 2 screws will be defective. Probability 0 defective and 2 is good. None of the 2 screws will be defective. So 2 is good and 0 is defective. 2 screw drawn. So 7C2, out of 7 good, 2 you have to draw, and out of 3 defective, 0 defective you have to draw. 10C2, total is totally 10, out of which 2 we have to draw, so 10 C2 by 10 C2 If you solve this one, you will get 5 by 15 or 7 by 15 or 49%. C is your correct answer. This is the end of ISRO 2017 RAC scientist solution. Thank you friends. Thank you for watching my video. Thank you.